right, we're going to do the first two questions on the 5152 combined review using your yellow notes. And as we do this, you might want to think about what you can put in that table that you can use for your next test. Show your work, sketch a graph on the right of the given equation. So we're going to identify key features, and we're going to sketch a graph when we're finished. All right, so here we go. To find, so this is standard form. And in this standard form, notice the A is 2, the B is -2, the C is -4. And the y-intercept is always, when it's in standard form, the y-intercept is 0, C. So my y-intercept should be 0, -4. Notice if we plug in 0 for x into that function, we do get -4. Our vertex, and again in our yellow notes, to find the vertex, it says calculate -b over 2a. That will get you the x-coordinate of your vertex. And then once you have that, you're going to plug that value back into the function and find the y that goes with it. So for my x value of my vertex, remember we're using h for that, we're going to do the opposite of -2, because that's our b value. We're going to divide by 2 times 2. So we get 2 over 4, which is 1/2 or 0.5. 1/2 or 0.5. I think I'll write it as a decimal this time. You could also write it as 1/2. Now to find the k value, the y value, the vertex, so this is my x value of the vertex, this is my y value of the vertex. We're going to plug that value back into the function. And we're going to grab a calculator and we're going to find out what our vertex is. Alrighty. So if we plug that into the calculator, we get -4.5. So our vertex is 0.5 or 1/2, and then -4 and 1/2. There's our vertex. Remember, your axis of symmetry is the line x equals -b over 2a, or x equals h. So our axis of symmetry is the line x equals 1/2. And we could use a 1/2 instead of a 0.5 if we wanted to. Direction of opening is up because a is +2. A is positive, so it opens up. And since it opens up, notice what we're going to have at our vertex is a minimum. Okay. We'll go back to the x-intercepts in a minute. Notice I can find the rest of the information just from what I already have. But we got to work a little bit to find those x-intercepts, so we're going to go after them in a little bit. Minimum value is what we have because it opens up. There's a low point. And that minimum value is y equals -4.5. My domain is going to be -infinity to infinity. And for the range, when the parabola opens up, remember it's square bracket and then the k value, which is -4.5. And then we're going to go to infinity. All right. And then for our x-intercepts, we're going to have to do a little bit of work. So let's go over here where we have a little bit of space and find our x-intercepts. Maybe I'll move it up just a little bit. So over here where I have some space to work, I'm going to find my x-intercepts. Notice it did say show your work. So for my x-intercepts, I'm going to solve the equation. 0 equals 2x squared minus 2x minus 4. So we'll have 0 equals, I'll factor out a 2 because we have a GCF. And then we're either going to use factoring by grouping or the box method. And we're going to factor that quadratic, x squared minus x minus 2. Let's see, let me review that process with you. We do a times c, but in front of that x squared we have a 1, and c is -2. We're ignoring the 2 that's out in front of the parentheses. A times c is -2. I need to look for two numbers that multiply to create -2, and they add up to -1, my b value. Let's see. Positive 1 and negative 2 will work. I'm going to draw a box and get my factored form. So I have x squared and negative 2 in the box. And then that middle term, negative x, splits into an x and a negative 2x. GCF for the top row, GCF for the bottom row, GCF for the first column, GCF for the second column. My factored form is x plus 1 times x minus 2. The front factor of 2 is never 0, so I really just need to look at when will this equal 0? When will that equal 0? We get x equals negative 1, x equals positive 2, and our x-intercepts are negative 1, 0, and 2, 0. And finally, it did say sketch a graph, so we're going to sketch a graph over here in this space. And here we go. So 1, 2, 3, 1, 2. So there's 1, 2, 3, negative 1, negative 2, negative 1, negative 2, negative 3, negative 4. We have to go just a small bit past that. I'm going to change colors here for a second, and I think I'll graph this in red. So what do we have? We have 1/2 sitting right there. Negative 4. So 1/2, negative 4.5 is our vertex. 0, negative 4 is our y-intercept. Let me move that down just a tiny bit. 1/2, negative 4.5. I've got x-intercepts at negative 1 and positive 2. And using that symmetry line, I can get a point right here at 1 and negative 4. And we'll graph our parabola up through, and we're done. Okay. All right. Problem number 2. Now notice the technique that we went through to find the x-intercepts. Okay. Here's how we found the x-intercepts. Set the quadratic equal to 0 and use the techniques from the previous unit to solve that quadratic equation. Number 2, we're going to do something similar to find x-intercepts. Okay, so number 2. Notice this one is in vertex form. Remember, to find the y-intercept, we set x equal to 0. So we'll plug in 0, and we'll find out that the y-intercept is that's going to be, you can use a calculator or you can go through the math without a calculator. 0 take away 1 is negative 1, but when we square it, we get positive 1. Negative 3 times 1 is negative 3, plus 12 is 9. So my y-intercept is 0, 9. The vertex should be easy because this is in vertex form. It's y equals a x minus h squared plus k. So the a is here, h is 1, and k is 12. Let me put those numbers in. Right? Y equals a times x minus h squared. What are we subtracting from the x? We're subtracting a 1, so h is 1. What are we adding outside of the parentheses? A 12, so k is 12. So our vertex is 1, 12. Means our axis of symmetry, it's always x equals h. The vertex is h comma k. Those are the letters we use for it. Axis of symmetry is always x equals h. Think about what you can put in the table to help you out here. Direction of opening is down because a is negative. All right, now before we do the x-intercepts, let me let me notice that since my parabola opens down, it will have a maximum point at the vertex, okay, because it opens down. And that maximum value is going to be y equals 12. My domain will be negative infinity to infinity, and the range will be negative infinity, because it's going to go down forever, but our largest y value is a 12, so we have that. Negative infinity to 12. Okay, let's go after those x-intercepts. So for the x-intercepts, we're going to solve the equation that we get when we replace the y with 0. So 0 equals negative 3 times x minus 1 squared plus 12, but I want the 0 over here. So I'm going to switch sides. Okay, now I'm going to subtract 12 from both sides. And I'm going to have negative 3 times x minus 1 squared equals negative 12. I'm going to divide both sides by negative 3. And let's see, I need a little more room here. So we're going to have x minus 1 squared equals 4. Now we're going to square root both sides, remembering to do a plus or minus square root on this right-hand side. So I have x minus 1 equals plus or minus 2. All right, so we have x minus 1 equals 2. We have x minus 1 equals negative 2. Add 1 to both sides, we get x equals 3. Add 1 to both sides here, we have x equals negative 1. So my x-intercepts are 3, 0, and negative 1, 0. We're just using techniques that we learned in the last unit. Okay, I am going to draw a quick graph here. So on my graph, I need to go up pretty high. I'm going to go up as high as 12, but I don't need to go very low. So I'm going to leave more space up above. And let's see, I got to go up to 112. A y-intercept over here at 3, and one over here at negative 1. And I think I'll count by threes. 3, 6, 9, 12. All right. My vertex is going to be at 112, so I need to go that high. And I'm going to change colors and draw in a lovely red. Okay, so my vertex is at 112, so over to x equals 1, up to y equals 12. I've got 0, 9 for my y-intercept. I can use the symmetry to go from the point 0, 9 across my symmetry line to the point 2, 9, one away on the other side of that axis of symmetry. If you want to, you can draw that axis of symmetry in, right? It's going to go right through the vertex vertically. So if we're 1 unit away on the left side, we go 1 unit away on the other side, and we get another point, right? Okay, let me go back to the red and finish my sketch. Intercepts, negative 1, 0, 3, 0, and then we'll draw our parabola opening downward. And there's our parabola. Okay. All right. Those are the first 2 problems in the assignment, and you're going to do the other 4.